Okay, let's do one example. So our first example, we'll say this: x squared plus 9y squared plus 2x plus minus 18y plus 1. And so you're just really going to have to look at this reference sheet pretty closely to understand like what you're doing. So you can know right away without doing anything, really, without doing any math or manipulating this equation, what type of conic section you have. So what type of conic section do I have? Well, I'm going to look at A and B. So A and B are the coefficients in front of the x squared and the y squared term. So A is 1, okay? A is 1. And then B is 9, okay? So because you have that happening, basically they're both positive. So I look through my list here and I'm like, okay, well, let's see. If A or B is equal to 0, well, I know that's not the case because this one's 1 and that's 9. Well, that's not the case. Is A equal to B? No. Is A not equal to B? Yeah. A is not equal to B. And are both positive? Yes. Okay, so then therefore, this is an ellipse. That's how you know that, by looking at this. So we know that this is an ellipse. A is not equal to B, and both positive. Therefore, we have an ellipse. And you'll do that depending on what type of conic you have. Now, here's the tough part, okay? You're going to have to rearrange the terms. So first step is rearrange terms. Oh, first of all, you want to ID the conic by looking at A and B. So you ID the conic, what I just did. Then you rearrange the terms to complete square for x and y. Yes, you will have to complete the square today. All right. So what I'm going to do is I'm going to rearrange the terms in such a way that it allows me to do that. And then I'm going to get this constant term on the right side. I'm going to get it off of there. So I'm going to subtract that 1 from both sides. But first rearrange. And rearrange like this. Watch. So I go x squared, and then I do my linear x term. So I go plus 2x. And then I leave space for adding the value to complete that square. Then I go plus 9y squared. So that's the y squared term. See? And now I subtract the 18y, the linear y term. Then I leave room to add something to complete that square equals, and I already took over that negative 1, or I subtracted 1 from both sides, so negative 1 on that side. Now, what I'm going to do is I'm going to add a value here to complete the square for x. And again, how do I complete the square for x? I do b divided by 2 squared, whatever the b term is for this. So right here is one perfect square potentially, which I'm going to create. And over here is another one, but I'll show you how to do that because that's a little bit different. So I'm going to complete the square first up here. So b is 2. I divide that by 2, and then I square it. So that's just going to be 1. So I'll add 1 to that. I've completed the square for x. So therefore, I'm going to have to add 1 to the other side as well, because I added 1 to the left. Add 1 to the right. Now, this is the tricky part, and that is this. First of all, I'm like encroaching on my problem here. Okay, so you can see the problem and the steps over here. I need to factor out this 9 here. I need to factor out the leading coefficient. Factor off leading coefficient. If I don't do that, then I won't be able to complete the square for this thing. So how do I factor that off? Well, it's pretty simple. I've got to get the 9 off. So I'll divide everything by 9 for the y term. Okay, so this is going to be the other perfect square, but I need to divide out that 9. So I'll do that. I go plus 9, and then I have inside y squared, and then I factored out 9, so I've got to divide that by 9 too. So negative 18 divided by 9 is negative 2, y, and now I've got this in here, which I'm going to add a value, and I'm going to just treat what's in this red parentheses right here as the square to complete. Okay, I ignore the 9 for now, and I just think about this as the b, just like I did over here. I just can't have the leading coefficient in there for that. I've got to factor it out. So I take that negative 2 divided by 2, square it, that's positive 1. So I'm going to add 1 over here. Now I added 1 inside the parentheses, but if I did that, I actually didn't add 1 to the left side of the equation. I added 9 times the 1 to that side of the equation because I have to distribute the 9. And I've gone over this before, but it was kind of tough for some of you, so I didn't really necessarily quiz you on it. What this means is you have to distribute the 9 to the 1, and really what you did is you added 9 to the left. So if I added 9 to the left, I've got to add 9 to the right as well. So these are both sides of my equation. Okay, I added 1 here, and I added 1 on the left. I added 9 times 1 on the left. I've got to add 9 times 1 on the right as well. So now, though, I have 9 on the right, because negative 1 plus 1 is 0, plus 9 is 9. And then I've got my complete square here. I factor. Actually, so factor off leading coefficient before completing square. Okay, if that's helpful, I don't know. And then I have to, okay, I have to factor both trinomials. For x and y. Okay, so I factor both trinomials. This factors into x plus 1 squared. Okay, so you need to know how to do that. X plus 1 times x plus 1. You just have to know how to do that. This right here in the parentheses factors into y minus 1 squared. But you've got the 9 in front of there. So you've got plus 9 and then y minus 1 squared. And then I said you had equals 9 on this other side here, equals 9. Now it's not kind of like super in line with it, but yeah, it's right there. So maybe I'll just put it in line with it so it's nice and clean, okay? Equals 9. So what do you do now, okay? We've identified this thing as an ellipse, okay? So because it's an ellipse, we need this side to be 1. So what we're going to do is divide the right side by itself to get it equal to 1. So let's do that. But then if we divide this by 9, we're going to have to divide every term on the other side by 9 as well. So I'm going to divide this by 9 and this by 9. Okay, so I did that, and now what do I have? I have pretty much my standard form. 9 divided by 9 is 1 on the right. That's what I need. So I've got x plus 1 squared over 9 plus, and the 9's cancel. So you've got y minus 1 squared, and that's technically over 1. Okay, equals 1. So we have our basic equation for the ellipse. And now we can identify what our homework is asking us for. I think I had it with me, but I'll just borrow this. Classify each conic section and write its equation in standard form. So standard form for me means what you already see here on the homework. But what I want you to do is write it in graphing form. So if you could take this homework here and write graphing right there. Because this is what I call graphing form. That's the form that I gave you in the first video where I went over all this stuff, okay? This is the only lesson that I'm going to have this week, by the way, I think. I might do another problem, make another video, but, okay, hang on. It says here, excuse me, hang on. For circles, ellipses, and hyperbolas, identify the center, okay? So the center is going to be HK. So H and K, make sure H and K are both opposite. So the center of this ellipse is going to be -1, 1, okay? And if you wanted to, you could graph it, but that's graphing form, okay? Right there, and that's what I need you to get. I need you to get this so that you can easily identify the center, and it is a center other than 0, 0.